Hello student, I am Dr. S.L. Munde, Assistant Professor Department of Mathematics, Sri RLT College of Science, Akola. Dear student, in this lecture we will see some problems on JPX and J minus PX. Okay, so in previous lecture we have seen general series of JPX and general series of J minus P of X. Okay, so these are given the general series of JPX and this is general series of J minus P of X. Okay, so this series is are very important to find out the solution of the next problem. Okay, now we will see some problems on this series. Okay, so what is the first problem? So prove that j half of x equal to root 2 upon pi x into sin x. Okay, so we have to show that this problem. Okay, solution, the general solution of jpx is given by, so by using this formula 2.9a, the general solution of the general series of the jpx is given by, that is jpx equal to 1 upon 2 raised to power p gamma of p plus 1 x to the power p minus x to the power p plus 2 upon 2 square 1 factorial p plus 1 plus 2 to the power 4 p x to the power p plus 4 2 to the power 4 2 factorial p plus 1 p plus 2 minus and so on. Okay, so this is the general series formula for jpx. Now in to prove this formula, we will put p equal to 1 by 2 in this formula. Okay, so j half of x equal to, so take x to the power p is common from all the terms, so we can write x to the power p means that is 1 by 2 divided by 2 raised to power 1 by 2 means root 2 gamma of p plus 1 that is 1 by 2 plus 1 that is 3 by 2. Okay, so here will be 1, here 1 minus here x to the power 2 x square 2 to the power 2 1 factorial p means 1 by 2 plus 1 that is 3 by 2 plus x to the power p is common x to the power 4 and here x 2 to the power 4 2 factorial, here p plus 1 means 1 by 2 plus 1 that is 3 by 2 and here p plus 2 means that is 1 by 2 plus 2 that is 5 by 2. Okay, so minus in this way we can put the values of p and we can write the steps. Okay, so dear student, we know that x to the power 1 by 2 can be written as that is under root x. Okay, so this is under root x upon under root 2 and we know that the gamma of 3 by 2, that is this can be written as gamma of n plus n plus 1. Okay, so that is 1 by 2 gamma of 1 by 2. The value of gamma of 3 by 2 can be written as that is 1 by 2 gamma of 1 by 2. So this is 1 minus x square and the value of this, that is 2 get cancelled, 2 into 3. Okay, so if you solve this, so you will get these steps. Okay, so now we know that gamma of 1 by 2 is under root pi. Okay, so putting the value of gamma of 1 by 2, that is under root pi. Okay, so this can be written as under root 2 and this is 2. So this can be written as 1 upon root 2. Root 2 get cancelled. So the total term can be written as, by using this concept, under root 2 upon 2x upon pi, 2x upon pi. Okay, so 1 upon x, 1 upon x we will take the common 1 upon x. So here will be x minus x cube upon 3 factorial plus x to the power 5 upon 5 factorial and so on. Okay, here we will take the 1 upon x is common term. Okay, and this is, we know that this is the formula of a sin x. So this is the formula of sin x. So this is the formula of sin x. So by using this formula, x minus 1 by 3 factorial x cube plus x to the power 5 upon 5 factorial, that is sin x. So putting using this formula, so the given term can be written as, so this x and this root x, so this can be become root x. Okay, so this can be written as 2 upon root pi x and this is nothing but that is sin x. Okay, so this is the formula. Okay, so this, by using this formula sin x we can prove this result. Okay, so therefore j half of x equal to under root 2 upon pi x into sin x, hence the result is proved. Now second result, we will see second problem. What is second problem? Prove that j minus half of x equal to under root 2 upon pi x into cos x. Okay. So similarly, we will prove this formula by using general series of jp of x. The general series of jp of x is given by this formula. So simple, we will put p equal to minus 1 by 2. In this formula, we will get minus j minus half of x equal to x to the power minus 1 by 2, 2 to the power minus 1 by 2, and this is nothing but will become, that is gamma of 1 by 2. Okay, so putting the value of p equal to minus 1 by 2, so you will get these steps. Okay, now here x to the power minus root by 2, so this can be written as, the whole term can be written as, that is root 2 upon root x. Okay, root 2 upon root x, and this gamma of 1 by 2, that is root pi. Gamma of 1 by 2, that is root pi. Okay, so we will get root 2 upon root pi x, we will take in combined term, and after solving this, we will get 1 minus x square upon 2 factorial plus x to the power 4 upon 4 factorial, and this is nothing but the series, that is cos x. Okay, so this is the series of cos x. Okay, so this is the formula of cos x. So putting this formula, by using this formula, we will get root 2 upon pi x into cos x. So therefore j minus half of x equal to root 2 upon pi x into cos x. Okay, now we will prove that third, that is we have to prove that j minus half of x equal to j half of x into cot x. Okay, so to prove this problem number 3, we will use example number 1 and example number 2. Okay, now we know that j minus half of x, that is this value, j minus half of x, that is this value, and j half of x, that is j half of x, where is j half of x, that is this value. Okay, so now we will dividing, j minus half of x by j half of x. We get j minus half of x upon j minus half of x divided by j half of x equal to root 2 upon pi x into cos x, root 2 upon pi x cos x. So this root 2 pi x will get cancelled, cos x upon sin x, that is cot x. Okay, then we will transfer this term to RHS side. So this can be written as j minus half of x equal to j half of x into cot x. Okay, so in this way we can prove the formula. Formula number 4, problem number 4, prove that j minus j 3 by 2 of x equal to root 2 upon pi x in bracket 1 upon x sin x minus cos x. Okay, we will see the solution. We know that the general series of the jp of x is given by, okay, so by using the general series of the jp of x. Okay, so here simple, we will put p equal to 3 by 2 in this formula, then we will get j 3 by 2 of x equal to, so take x to the power p is common from this, x to the power p common, x to the power p common. So here will be x to the power 3 by 2, p means 3 by 2, upon 2 to the power 3 by 2 gamma of p plus 1, that is 3 by 2 plus 1, that is 5 by 2. Okay, so here we have taken x to the power p common, so here will be remaining 1, here x square, and here x to the power 4. Okay, so putting the values of p in this term and solving, we will get these types of term. Okay, now we know that gamma of 5 by 2 means, after solving this, so this is x to the power 3 by 2, okay, and 2 to the power 3 by 2, so this can be written as in this way. Okay, so by using this formula, gamma of 5 by 2 means 5 by 2 gamma of 3 by 2 3 by 2 gamma of 1 by 2 gamma of 1 by 2, that is root pi. Okay, so by using that formulas, we will come here. Okay, so in bracket 1 minus x square upon 2 into 5 plus x to the power 4 divided by 2 into 4 into 5 into 7 and so on. Okay. Now we will transfer this term to left hand side. So this can be written as root pi x upon 2 j 3 by 2 of x equal to, okay, only we will shift this term root 2 upon pi x. So here will be only remaining, so multiplying x square to this term, so 1 by 3 as it is, x square, x to the power 4, x to the power 6 and so on. So we will get these steps. Okay. So what is next step? Now we will one upon 3. Now we will multiply 1 upon 3 to this term. Okay. So this can be written as x square upon 3. Now here we will multiply and divide by 2 by 2 for the simplification. 4x to the power 4. Okay. Here we will multiply 4 dividing and numerator. Here we will multiply and divide 6 numerator as well as denominator. Okay. Multiplying to this term we will get these steps. Okay. What is next step? So here 2x square upon 3 factorial we can write. Here 4x to the power 4 upon 5 factorial and plus 6x to the power 6 upon 7 factorial we can write. 3 factorial, 5 factorial and this is 7 factorial we can write. Okay. Now we will take x square common from this. So this will be remaining, that is 1 upon 2 factorial minus 1 upon 3 factorial x square. We will take x to the power 4. We will get 1 upon 4 factorial minus 1 upon 5 factorial. Similarly 1 upon 6 factorial minus 1 upon 7 factorial x to the power 6. Okay. So in this way we can take the common terms. Now we will combine x to the power 2, x to the power 4, x to the power 6. Okay. Then minus x to the power square, x to the power 4 and x to the power 6. Okay. Even term as well as odd term. Okay. So multiplying this term to this, multiplying to x square, x to the power 4 and x to the power 6, this term, and combine we will get these steps. Okay. So here we will take, so this is nothing but, so taking x square is common, so this can be written as minus, we can take here this term, or we can write these steps as it is. Okay. So minus 1 minus or we can say that after solving these two brackets we will get, so this bracket will be, that is minus, this is the bracket of cos x. Okay. So 1 upon x, x minus x cube upon 3 factorial plus x to the power 5 upon 5 factorial and so on. Okay. And this is nothing but the series of sin x upon sin x, and this upon x, that is x. Okay. So this is sin x upon x minus cos x. So therefore j half 3 of x equal to root 2 upon pi x into 1 upon x sin x minus cos x. Okay. So in this way we can prove the problem. Problem number 5. Okay. So so in similar manner we can show that the problem number 5 for the p equal to minus 3 by 2. Okay. So in similar manner we can prove the problem number 5. Okay. So if you go to step by step you can solve all the steps. Okay. So this problem is same as a problem number 4. Okay. Now problem number 6, that is prove that j half of x bracket square plus j minus half of x bracket square equal to 2 upon pi x. Okay. So to prove this problem we know that the example number 1 and example number 2. So by using example number 1 and example number 2, first we will take the square of both example number 1 and example number 2. First we will take the square of the example number 1 and example number 2. Then we will add that example number 1 and example After squaring, then we will add that both example. So adding and squaring both example, we will get 2 upon pi x sin square x plus cos square x, and this is nothing more that is 1. So therefore this is the required result of the example number 6. Okay, so in this way we can solve the problems of a general formula jp of x and j minus p of x. Okay, so in next lecture we will see another point of this unit.